Today, the curious topic we are going to see refraction. We know what is refraction, what causes refraction, why this refraction should happen. This refraction, like this, the ray coming, and this is one medium, the ray coming and bends, ray coming and bends, like this, ray coming this way or this way, or if it comes this way, why should, how this happened in this way, in this way, in this way, how, what causes these directions of refraction, and we are going to see the principle of reversibility in this video. Now we know that already light travels with different speeds in different media. Correct, children? Sure? The frequency only remains same, but the light travels with the different speeds in different medium. Why? So if you take water and air, okay, water and air, the water has stronger, that means the particles are much closer together than air. So now once again, this is water, so this is in our control. So this water is closely packed. So if I push this way, it takes some time and comes to rest, and it is in our control. This water's particles are somewhat closely related, that not closely packed. But now this is air. In my hand I have air, so I have pushed the air. The air particles are loosely packed, so I can easily push this air, but I can't easily push this water or pull this water. So how the condition within us, the same within the water and the material. Clear? Likewise, water, if you take any other, like this scale, okay, like the scale, if the, see, my tube light comes over here, this light comes with a speed till this, and this thickness is there, no, here it changes direction and comes, so that's what only we get changed these words in the scales, okay, but it is in a position, actual position is different from the position which we are seeing now. So okay, clear, children? If I take this is the original position, but if I gave this scale, this is not the original position which we are seeing through the scale. This is the original position of this word, but this is not the original position of these words, because of refraction. The light rays which are traveling through this medium refracted because of the particles of this scale, okay. So but the frequency remains same. You should not confuse with the frequency and the wavelength, okay. So the bending of light or refraction, okay, or refraction occurs due to the change in the speed of light, as in the speed of light, okay, as it passes from one medium to another. Okay, larger, okay, note this, larger the change in the speed of light as it passes from one medium to another, more is the bending due to refraction. Clear, children? So how much change is there with the speed v1 and v2, that much of refractive index increases. What is the simple definition, simple understanding of refractive index is, how much, if the refractive index is greater than 1, the speed reduces. Okay, I will write the relation. Okay, we know that nu, okay, nu 2 with respect to 1, medium, refractive index of medium 2 with respect to 1 means sin I by sin R. Snell's law, according to Snell's law, we have V1 by V2. If it's V1 going to be air, vacuum, then C by V. Correct, children? This is the speed of light in vacuum. This is the speed of light in medium. Okay, clear? Now, we can easily write the relation that if V1, that is the medium, this is the medium. If you take, this is one medium and this is one medium. If this is something, okay, some medium over here. So the light rays comes obliquely. Now these things we are seeing only oblique condition. If it comes normal, it goes normally, but we are not seeing normal condition, we are seeing only the oblique condition. So it gives oblique with the plane, this plane, and if it bends towards normal, then the refractive index is greater than the refractive index of 1. So you can write this is refractive index 2. This is refractive index 1. So this is the refractive index of 2 with respect to 1. Refractive index of 2 with respect to 1. This is I, this is R. Okay, sin I by sin R. I told you already the refractive index, this derivation somewhere. Okay. Now this is speed of light in this medium. Okay, this medium, how much the speed in this medium, and this is how much the speed in the medium 1. This is medium 1, this is medium 2. Okay, now if the speed of light in medium 1 is V1 is greater than V2, then we will know that the refractive index of 2 will be greater than 1. Sure, because the speed reduces. If the speed reduces only, it comes close to the normal. If the speed is increased, then it moves away, freely it moves from the normal. The speed is reducing, so it's slightly coming to the normal. That's it. So nu2, that is this refractive index, is greater than 1. Greater than 1. So the speed reduces, and then sin I will be greater than sin R. How will you say that? Easily you can say, children, sin I is greater means if it going to reduce its speed, I told you it will be coming close to the normal. Then the R will decrease. Come chote I na, sin I is greater than sin R. So sin I is greater than sin R. Okay, children. Now the next relation. Okay, the next relation is if V1 is less than V2. Okay, then V1 is less, V2 is greater. Again I will draw another medium. This medium, if you take, this is one medium. The light rays comes. Okay, this is the normal. The light rays move away. This is towards, this is moving away. I have to put the arrow mark, no? Moves away. So this is I, this is R, this is new 1, this is new 2, and medium 1, medium 2. Clear? Now this angle is increasing, means the speed is increasing. If speed is increasing, it will move away from the normal. Correct? So the speed is increasing. Then if speed increases, what will be the condition for the refractive index? It will be less than 1. So sin I will be less than sin R. Easily you can understand. So the ray of light bends away from the normal as it refracts from a denser medium to rarer medium. So now it is the important condition. This is going to be the denser medium. If the ray is close towards the normal, then it is the denser medium. So I will write this relation. Denser medium. Okay, children. Denser medium light ray will be close to normal if it is a rarer medium. Okay, rarer medium, light ray will be away from the normal, away from normal. Okay, clear? So this tricks and all you should remember. So this is why the refraction takes place. Clear, children? Because it totally depends on the particle nature of the medium as well as the speed of the ray comes in. Then principle of reversibility we have to see. Clear? Yeah. Now we are going to see the principle of reversibility. Okay, first before entering into the derivation, we should first be clear with the definition. So now it is the definition. If final path, okay, final path of a ray of light after it has suffered several reflections and refractions is reversed, it retraces its path exactly. So to explain with the diagram, I have a medium, separation, and normal over here, correct, normal, and then the incident light, correct, the incident light, and then the refractor. I have a plane mirror over here, so plane mirror. Clear, children? This is a plane mirror. Then the path is in this way first, and after reflection how it retraces its path is, to say clearly, this way itself. So on the line itself you can put the arrow marks. Comes refraction, reflection, retraces its path in the same manner. This is a particular ray. Millions of rays, millions of paths, the same path. Okay, so I'll consider a ray of light AB. Okay, so we'll consider a ray of light. This is AB. AB is incident to this plane. Okay, let's take it as X and Y. This is X, this is Y. So this AB is incident to XY. Then is incident angle, and then this is the refracted angle for this AB ray, and okay, now angle A B, let's take it as N and M. Okay, so A B N, A B N I is incident angle. Okay, incident angle on XY. Correct, children? Angle of incidence ABN is I, and angle of refraction, this is C. Let's take ABC. CBM to be R. This is C. Okay, C. CBM to be R. Then according to Snell's law, this is Snell's law. Okay, what can we write? Sin I by sin R is refractive index of 2 with respect to 1. Okay, so this is for the refraction. Then for reflection we will write the reflection rays. This acts as the incident. This CB is incident. Okay, incident to XY. This is the reflection condition. I will write that clearly. This is refraction condition. Refraction. This is reflection condition. Okay, children, be clear with the concept always. Don't read anything with confusion. Okay, CB is incident to the XY. Then R acts as CBM. CBM acts as incident ray, and then ABN. ABN acts as refracted ray, reflected ray. Okay, refracted ray. It's changing its speed, no, refracted ray. According to same Snell's law, sin I by sin R is refractive index of 1, because the goes to the medium here only, no, from 2, the same order, from 2, from where to 2, from where to 2, from this to 2, from 2 to 1, correct, from medium 2 to 1. So new from 2, from where, from 2, from should come here, 2 will be here. 2 means TO2. 2 where it reaches should be here, where it starts should be here, from to 2, this order. Okay, children, clear? Okay, now if we multiply, okay, let's take it as equation 1. This is to be equation 1, this is to be equation 2. Okay, now if you multiply these two, okay, equation 1 and 2, we get sine 1 into 2. Okay, so sine okay, I have to change. Oh, sorry, children. As this is acts as the incident ray, which acts as the incident ray? This, the other alternate, so it should be R, it should be I. Clear? The alternate, no, this is the incident ray. Sin R by sin I, no, don't confuse. Sin R, it's going to be the incident ray, so sin R by sin I. So sin I by sin R into sin R by sin I. We children, if I make mistake, you should think how it will be coming. Okay, let's wait. What's going to happen? Okay, so 2 1 into 1 2, cancel, 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 cancel. What we get over here? 1. So as clearly we can say that it's back to 2. So finally we got the solution. What we can say from here? The refractive index of medium 2 with respect to medium 1 is reciprocal of the refractive index of medium 1 with respect to medium 2. This is what we are proved here. Hence proved. Okay, children. Thank you for seeing this video. If you have any doubt, comments in the comment section. And if you like the channel, if you want to learn more in an interesting way, you please subscribe our channel. Bye bye.